Hello, let us talk about a geometric sequence. So a geometric sequence is also a type of a number pattern, but then this one is different from an arithmetic. Remember last time on our previous video, we talked about an arithmetic sequence being a sequence that has got a constant difference. But then here we go to a geometric sequence. So a geometric sequence is different. It is because that to get to the next term, you have to multiply a certain number, and we call that number a ratio. So welcome to Edu-ca-te. Today we're going to be talking about a geometric sequence. So here you can see that to get to 4 from 2, we can either add 2, but then we cannot carry on with the pattern. If we add 2 here, we are supposed to get 6. So that makes it not an arithmetic sequence. So here, in order to get from 2 to 4, what do we have to do? We have to multiply by 2. And then to get from 4 to 8, we have to multiply by 2, because 8 divided by 4 is equals to 2. And then to get from 8 to 16, we also have to multiply by 2. We can do this all day, but then this evidently tells us that this is a geometric sequence. It is because we are multiplying with the same number, and we call that number a constant ratio. So here, we could keep on multiplying by 2 until we reach term number 1000 or wherever the terms can go to. But then here, we must have a certain general formula that can help us to get bigger terms. So you can see that this is your term 1, first of all. This is your term 2, this is your term 3, this is your term 4, this is term 5, and so forth. What if we were asked to calculate the term number 100? Are we going to keep on multiplying by 2 until we reach term 100? That's going to take a long period of time. But then we can use a general formula that states that the term position is equals to a multiplied by r to the power n minus 1. Okay, so let me explain the formula. The formula has got here, first, this is your Tn. Tn tells you the term position or the number which you find on a certain term. For example, term 1, you find number 2. So your Tn for term 1 is 2. Your Tn for term 2 is 4. Your Tn for term 3 is 8. And so forth. So this is your term position. And then you have got your equal sign there. And then this is your A. Your A is always the first term, even when it comes to an arithmetic sequence. So symbol A tells you about your first term of the sequence. It is the term that appears first in the sequence. So here you can see that you've got your R. Your R, it is your constant ratio or the number which you multiply with to get to the next term. And then your N tells you about the term number, or actually what term are you on. For example, we are on term 1 here, and we are on term 2 here, we are on term 3 here, we are on term 4. So that is the value of N. Please do not confuse Tn and N, because they seem similar, but then they are not the same. So here, let us try to find out what is the general formula we can use to get more terms in the sequence. So here we can go Tn is equals to, we substitute our value for A, which is 2, multiplied by our ratio, which is constant, is positive 2, and then to the power of n minus 1. We do not substitute anything on n because n can be any term number. We can go to term 100, term 50, everything else. So here we can go and say that please do not make this mistake that you multiply 2 and 2 and you be like 4 to the power n minus 1. This is completely and totally wrong. Why is it wrong? It is because these two are not like terms. You are not supposed to multiply them. So here you can go and substitute 2 here, and then 2 to the power of, let's say, you can see that this is your general formula. So we just want to prove it if it's correct or not. What if we were to put term number 1? We want to see exactly what's on term number 1. We're supposed to substitute 1 minus 1 here, and then this is 2 multiplied by any number which is raised to the power of 0. Since 1 minus 1 is 0, it's going to be 1. So this is 2 times 1. Therefore, your first term is equals to 2. So you can see that this is what? This is your first term. So what if we were asked to calculate term number 3? We're going to use our general rule which works for every term in this sequence. We're going to say term number is equals to 2 times 2 to the power n minus 1. We're going to substitute here 2 to the power of 3 minus 1. So it means we're actually calculating term 3. This number and this number must always correspond. So here, if we're going to say 2 times 3 minus 1 is 2 squared in this case, and then you've got 2 multiplied by 4, and then you find out that your third term is equals to 8. So this is how it works with a geometric sequence.